Okay, I think we're ready to, like, do you have any questions? Any questions on anything?
I have 2 questions on 4.3, numbers 5 and 9.
Page 49. 5. So, and we're just supposed to take that first derivative, right? So we use the chain rule on it, because there's these 2 parts. So we'll take the derivative of the first. That's what you did. Times the second. And then plus the first times the derivative of the second. And that's 1 over 3x. And then the derivative of what's inside here is 3. So then that simplifies into 2x, ln of 3x. And then one of these x's goes away, so there's 1 there and there. 3 goes away. But I put an equal sign. Plus. And that's an x. Is that what you got? Oh, do you see what I did?
Yeah.
When you said 9?
Yeah.
Okay. So 9 is f of w. This is ln of w plus 4. So when you take the first derivative, it's going to be that bracketed item. So there's a 3 comes out in front of the bracket. ln of w plus 4. And then it's drop that 3 to a 2. And then it's what's inside there. So it's times, and that's 1 over w plus 4. Derivative of ln w plus 4 is 1 over that. And then it's the derivative of what's inside. And that's just 1. So this would be just, probably write it like this. Does that make sense? Any other, yeah, Joel? 11? So f of t ln square root of 3t plus 5. So what I'm going to do with this first is I'm going to write this as ln, write this as a fractional exponent. That's just f of t. Now I'll take the first derivative, and that's 1 over 3t plus 5, 1/2 power. Then it's the derivative of what's inside. So that's 1/2 3t plus 5 to the negative 1/2. And then what's inside that, the derivative of that is 3. So then if you simplify that, this 3 stays in the numerator. And then there's this 1/2 is down in the denominator. This thing comes down, and it's 2 square roots, same value, so it's just 3t plus 5. And I guess you could either leave it like that, or you could distribute that. I don't know what 6. 6t plus 10. I think that's about as low as you can go with it. But you see, you understand, this is actually in the denominator. Along with this, the same value, so then it makes it just 3t plus 5. Do you want me to do more to it so you see it, or do you see it?
What happened in front of the yellow there?
That what I did was it comes right down here.
But that came from the text point?
I think you're right, it should be a negative. It should be a negative, which would make this a negative. I think. I gotta think about that. No, that's just a plain plus. I had it right. Because you're taking the derivative of this thing right here. And when you take the derivative, that's a positive 1/2, and then you reduce the exponent by -1. I think it's right. Anything else? All right. So, what we're doing now is we're doing, rather than logarithms, derivative, we're differentiating an exponent. So with this one, okay, let's start out. What we have is this e to the x, and then we're taking d of e to the x dx. And what that turns out to be is e to the x. It's just like on the previous section, we went d of ln of x over dx is 1 over x. So we're just defining, this is definition. The proof of it is right above. I guess you could call it a theorem, but for the way we're doing the problem, it's a definition. And then we're going to show you chain rule for this. The derivative, if you have e to the g of x, it's some function up there, dx. So then it's still e to the g of x. And then it's going to be times the derivative of g of x. It's just like if this x, when we did this one, d of ln of g of x over dx, we did 1 over ln of g of x. Then we did the derivative of g of x. So it's the same concept. And then there's interpretations there on page 357. Then there's one more derivative that they're saying is that they say if you do the derivative of e to the ax dx, and this is a e to the ax. So these, and you can get this right here by applying this chain rule. Okay, any questions? Number 2, we have f of x equals e to the minus 4x plus. So when we do the derivative, this is the chain rule. This is going to be e to the negative 4x plus 6 times the derivative of the exponent, which is a minus 4. So this is going to be a minus 4 e to the minus 4x plus 6. And that's what the derivative is. Or well, rather than doing this one right here on that one, I'd rather stay with the chain rule. So it's e to the 8x, and then the derivative of the exponent is 8. That last thing would say that you could go e to the 8x and go straight to it. But if you want to do one less thing to memorize, rather than going from here straight down to there, by rule 3, you could do it that way. That's 6. So it's f of x e to the 2x cubed minus x minus 7. So the first derivative is going to be e 2x cubed minus x minus 7. And then the derivative of the exponent. So, and this is just a polynomial derivative, so that's 6x squared minus 1. Now, if you want to distribute this e to the x across it, then you could have 6x squared e to the 2x cubed minus x minus 7 minus e to the 2x cubed minus x minus 7. What I'd take is, I'd take this or that one, whichever way. You'd want to do it. So 8 is f of x 4x squared plus 5 e to the x squared plus 1. So the first derivative, you're going to take the derivative of the first term, which is going to be 8x to the first, plus it's going to be 5e to the x squared plus 1. Then times the derivative of the exponent, which is 2x. This is going to be 8x plus 10x e to the x squared plus 1. Now, in the text, I might factor out a 2x and have this as 4 plus 5 e to the x squared plus 1. If you get it to here, it's okay with me. This is probably what you'll see in the book. And 6x cubed 2b 2x plus 1. Okay. I think what they're doing here is they're wanting you to think of this as that times that. So then the derivative of the first is going to be 18x squared. And then it's times 2e to the 2x plus 1. And then it's going to be plus 6x cubed times, and then it's 2e to the 2x plus 1. And then times the derivative of the exponent, which is 2. So this 2 times 18, 36, x squared e to the 2x plus 1 plus, this is going to be 24 x squared e to the 2x plus 1. And if you were to take out common factor, the x squared would come out, the e to 2x plus 1 would come out, and then 12 would come out. Okay. Let's see. What it is. That term right there, and that term are identical. So you have 36 of them and 24 of them. So you have 60 of those. Oh, here it is. So this is 6x cubed right here. Okay, then that's a cube. Now then, that's not going to work. Okay, now when you factor out, you're going to factor out 12. X squared e to the 2x plus 1. And then that'll be 3 plus 2x. That's what it is. Because this term came down right there. I brought it down incorrectly. Yeah. This, you mean this one right here?
Yeah, the first derivative. Oh, just the whole. More than me about the first part.
How do I get this part here?
Yeah. I looked at it. I just.
Okay. The second one is, it's the first term, that's the thing I brought down incorrectly. That term has to come down, this one right here. Right to there. And then you take the derivative of this term, and that's the 2e to the 2x plus 1, and then times the derivative of the exponent. It's, before you came, the derivative, if you look back on page 353, when you take the derivative of like e to the x, that is e to the x. So when you're taking the derivative of this thing right here, when you take the derivative, it's 2e to the 2x, because that's what that is. And then the chain rule says that if you have a value up in the exponent, and that's e to the g of x, and you have to take the derivative of g of x. So see, this is really this part right here, or this part if you want. And then this is the derivative of the exponent. Yeah. Well, f of x e square root of 5x plus 2. What I'm going to do is I'm going to rewrite that exponent as fractional. For 1/2 power. I'm going to take the first derivative. So the first derivative is just that thing, that exponential function. Then it's times the derivative of the exponent. Derivative of the exponent, I bring the 1/2 out in front. So 5x plus 2, drop the exponent by minus 1, so it's a minus 1/2. And then the derivative of what's inside, and that's going to be 5. So then, the 5 halves, I can write that out front. So it's 5 over 2. What's in the numerator is e to the 5x plus 2 to the 1/2. And then this thing right here is in the denominator, because that negative puts it down there. 5x plus 2 to the 1/2 power. Now, if you wrote that as, rather than fractional exponents as radicals, it would be 5 halves e to the square root of 5x plus 2 over 5x plus 2 radical. Now, I'd take this, or this one. I don't know what the book does, maybe the second one. See this right here, this puts it in the denominator. 18. So it's e to the 3x. ln of 3x. So this is a chain rule. I take the derivative of the first. So that's e to the 3x, and then there's a 3, but I can actually put this 3 out in front, right? And you take the derivative of the exponent. And then it's ln of 3x. Plus, it's the first term. And then it's derivative of the second, so that's 1 over 3x. And then times the derivative of the argument. So then if we took a common factor out, we'd have 3e to the 3x. Then that'd be ln of 3x. Plus. What's that? What?
So the derivative of 3 to 3x.
Yeah.
So you get 3
Yeah,
3x?
yeah. You get e to the 3x. It's either the derivative of this one right here is either applying the chain rule on 355, or else you apply the rule on 357. Now 357, when you take the derivative, it's just this 3 is out in front, e to the 3x. So on 357, let's see what that rule says. It says when you have e to the ax, well, that's e to the 3x, where a is 3, is a e to the ax. This is 3 e to the 3x. Basically, you go back on page 353, and that's what I was saying. When you take the derivative of e to the x dx, it is e to the x. It's just the exponential. Okay. So it's f of x equals e to the 2x. So if you take the first derivative, it's going to be e to the power e to the 2x. Now times the derivative of the exponent, so that is going to be e to the 2x. Then we have to take the derivative of that exponent, which is 2. So this is 2 e to the 2x, e to the 2x. Now, what you can look at is, you can look at these bases are the same. So then you can write this as 2e to the 2x plus 2x. Because when the bases are the same, you add the exponents. So this is what you'll see in the book. of x, 3x minus 2 e to the negative 0.04x. The first derivative is the derivative of the first term in that binomial, so that's 3, minus the derivative of the second. So what that's going to be is 2 e to the minus 0.04 x times the derivative of the exponent, which is negative 0.04. And that, so this is going to be a plus 0.08 e to the negative 0.04 x. So that should be it. So any questions on that? 21 through 24 said use implicit differentiation to find y prime. It's 7x squared y plus e 4x y squared equals 1. So we implicitly differentiate that. So this is the derivative of the first term is going to be 14xy plus, and then it's going to be 7x squared, and then it's y prime plus the derivative of the second term is e to the 4xy squared times the derivative of the exponent is going to be the derivative of the first, which is going to be 4 times the second y squared. I'm going to put a bracket here, plus the first times the derivative of the second, 2y, the first, y prime. And then the derivative of the constant is 0. So now what I got to get is I got to get that y prime by itself. That's y plus x squared y prime. I'm going to have to distribute this through there. So this is 4y squared e to the 4xy squared plus, that's 8xy e to the 4xy squared times y prime. So I want to keep these two terms on the left and put those other two terms on the right. So I got 7x squared y prime plus 8xy e to the 4xy squared y prime equals a negative 14xy negative 4y squared e to the 4xy squared. And I'll factor out a y prime. 7x squared plus 8xy e to the 4xy squared y prime. And divide both sides by this term right here. So it's y prime equals I don't know whether I'm just going to leave it with negative 14xy minus 4y squared e to the 4xy squared all over 7x squared plus 8xy e to the 4xy squared. Now the numerator only has a 2y in it, and the denominator only has a common x. So whether you factor that out or not means nothing. So this would be implicitly differentiated then. That's the next problems. It says find the second derivative. So 26 f equals e to the minus x plus e to the x. First derivative. So it's the derivative of the first term of that binomial term. So this is going to be a negative e to the minus x plus, and this is just e to the x. Then you take the second derivative, and it's going to be a negative and negative. So this is e to the minus x plus e to the x. So that's the second derivative. Same as the function. Next problems. It says find and interpret each derivative. Okay. 28. Says f of x equals negative 0.06 e 2x plus 5. First derivative is equal to a negative 0.06 e to the 2x plus 5 times the derivative of the exponent, which is 2. This is a negative 0.12 e to the 2x plus 5. And then it says f of 3 0.12 e 2 times 3 plus 5 negative 2 e to the 6 plus 5, which is 11. Now, if we wanted to get an approximation of that number, we have to go into our calculator. And find it. minus 0.12 equals equal to minus 0.12 second e raised to 11. So, let's see. This is 9. So the interpretation is as x goes from 3 to 4, f of x, it actually increases. By 7184.9. Because if that were a plus, if this were a plus, it would decrease, right? But it actually increases. This is pi. Okay. I got a quiz.
Why, if it was positive, why would it decrease?
Negative. It seems like it, if you think about the way it, e to an exponent ought to be a group. It seems like it should decrease. And maybe what you're saying, maybe this should decrease. Because an exponential function, if that, and that base, when this base is greater than 1, it should basically go like this. Go through 0, 1. But then that negative in front of it, that negative 0.12, flips that thing over, makes it go this way. So as you go to 3 to 4, it must be decreasing. I must have said it wrong. It must be wrong. What you're thinking must be right. Yeah. Do you understand what I'm reasoning out? An exponential function should, if this is, without looking at this thing should look like that. It should be something that grows. Because the base is greater than 1 exponential function. And then that negative sign should flip it.